Hello, my friends. This is Deepak Chopra, and we are back here talking to luminaries and scientists and philosophers and everyone who wants to understand what Professor Sean Carroll calls the big picture. It's a perfect title for this amazing book on the origins of life, meaning, and the universe itself. I have to frankly say that although I've read hundreds, if not thousands of books on the nature of reality, this particular book, and I recommend this to everyone, is probably the magnum opus for our times. If you want to understand the current models of what we call reality, both fundamental reality and perceived reality. This is it. So please look it up. There's no way we can discuss all the topics here, and everything is included here. I've made notes. I've read it about twice, and I intend to read it many, many times in order to fully grasp everything that Dr. Carroll has written about. And then, of course, we have this new bestseller, Something Deeply Hidden, which actually is even more thought-provoking than this book. But I think this leads into this, but we'll talk about that in a moment. So, Dr. Carroll, first of all, thank you so much for joining me here. I've read all your credentials and they're all over the place. You're a luminary. I watched you speak in Cambridge and the Darwin series and all of that. And it just means a lot to me that you have taken the time to speak with me. So thank you.
Well, thank you very much for having me on, but please call me Sean, not Dr.
Okay,
Carroll.
I'll call you Sean. So here's the story. I don't know the exact month, and I was going to look it up when I was going to speak to you, but then I didn't have the time. 1969. Um, I don't know how old you were. I think I'm 20 years older than you are. But 1969, I was a medical student in India, and I was in my final year, and I was in a little village outside of Delhi. Now, I had never seen technology in my life until I came to the United States in 1970. I had never even seen a television set. And of course, then there was no internet and no fax machines and nothing that we so assumed. Right now my grandkids assume this is normal, everything that we're doing, including this Zoom conversation. So one day I'm here, 1969, and the villagers bring in a young boy who was about 14. Now I had a little piece of technology in this village. There was very little electricity, very little running water. But I had one piece of technology. It was an AM radio. And that was my only connection to the outside world. So this particular day, the villagers bring in a young teenager and say, in their words, he's gone mad, he's psychotic. And he needs institutionalization forthwith. I said, what's the matter? He said, he just came back from Delhi and he's saying that men have landed on the moon. And it's impossible. So I said, actually, they have, And then they looked at me as if I was totally crazy. So then to settle matters in this village, you go to the elders. And there's a tradition that there are 5 elders that are basically run the village through their wisdom. And the eldest of the elders is supposed to be the wisest person. So we went to him and we said, can you settle this for us? Have men really landed on the moon? Because these guys are saying it's sacrilegious. They worship the moon. They have rituals. They worship the moon. And the elder said to me, there are many kinds of moons. There is a physical moon that men who are also physical entities have landed on. There's a romantic moon, Romeo and Juliet, and Laila and Majnu, and, in India, Shiva and Shakti. There's an emotional moon, romantic moon. there's another moon that we don't understand. It kind of recycles in every species as their biological rhythms. You know, horseshoe crab has never seen the moon, but comes from the depths of the ocean to mate and lay eggs. That's a horseshoe moon. And then there is a mathematical moon, and then there's a spiritual moon. I said, what is the spiritual moon? He says, all of them. That's all possibilities. It's the potential moon for every possible experience. That's the spiritual moon. So, you know, that kind of reminded me of what you will be speaking about in this book. There's naturalism and there's poetic naturalism, without which there would be no meaning and purpose and cause and effect, or what in the East we call karma and all of that, without um, the other moons. And, you know, I was also reminded of something that Einstein is supposed to have said. The moon would still be there if no one was looking. So that leads me to actually some of the most important things you address in this book, because this is the state of the art of current scientific knowledge of what we call existence or reality. Now, of course, you know, depending on many cultures, even existence and realities in India and the Upanishads, we don't even use the word reality. The only word that's used is existence. And by existence, we mean anything that is perceived or understood, which requires cognition, perception, thinking, reflection, thoughts, emotions, feelings, all that appears on the screen of our consciousness. And so my first question here is, you are describing in this book really two types of existence. One is our perceptual experience of reality, and the other is what you might call fundamental reality. I had the opportunity to recently speak to your friend Frank Wilczek, and he had some interesting things to say about all the topics that we are discussing. So my first question to you, sir, is, I'm happy to call you Sean, but I respect you tremendously, is why did you write this book? You're a physicist, you're a theoretical physicist, your strength is mathematics, but you took that to the extreme here. Why did you write this book?
Yeah, no, I mean that's the right question to start out asking, because it's not simply a book where I'd say, well, here's the latest wrinkle in physics or cosmology. Here's an idea that we've established, and let me explain it to you. It's a much more, it's a broader book, and it makes an argument. It's not just saying things that everyone agrees with. You can disagree with it in places, but it's also a very interdisciplinary book, and that's intentional because I think that, you know, I'm a big believer in expertise. I'm a big believer that it's important to listen to people who are specialists in their area. But then once you listen to them, you need to think about it, and you're allowed to talk about it. And someone has to take ideas from different areas and synthesize them. And so I thought that, you know, this was a pass at explaining the underlying features of reality from one point of view, and explaining how different aspects of reality fit into them. So there's a physical world, and then there's a biological world, and there's the world of judgment and aesthetics and morals, and how does all that fit together? That's what I meant by the big picture.
But you also say in this book that there's a possibility that all these issues, morality, behavior, understanding, imagination, insight, intuition, creativity, ultimately may be explained through physical laws, through mathematics.
That's right. So, you know, there's a possibility is an important statement there, because I don't think you should ever be too definitive about these kinds of questions. Even if you think, well, I know it well enough, you should still be open-minded about changing your mind. But yes, the point of the book is to, like you said, defend the position of poetic naturalism. And the naturalism part of that phrase is there is only one fundamental underlying world, the natural world. There's not a separate realm of ghosts and spirits. There's not a separate realm of minds and feelings. It's all ultimately, in one way of talking about it, the natural world doing its things, including you and me obeying the laws of physics. But then the poetic part of it is that there are many ways of talking about that natural world. You know, as a fundamental physicist, I can talk about quantum fields and the wave function and, go very deep. But someone else who might be interested in, more material objects might talk about chemicals and materials and substances and tables and chairs. Someone who's interested in the psychological or political realms will talk about people's feelings and attitudes and emotions. And these are all valid ways of talking about the world. And the point is they have to be consistent with each other. They're different approaches, different vocabularies to talk about the same underlying thing.
That's very beautifully said, sir. But as I read your book, you've addressed just about everything. So, if you don't mind, I'm going to read the titles.
Do not mind that.
I want our audience to read this book and educate themselves. So here we are, Part 1, Cosmos, the fundamental nature of reality, poetic naturalism. The world moves by itself. What determines what will happen? Reasons why, our universe, time's arrow, memories and causes. Part 2, understanding, learning about the world, updating our knowledge. Is it okay to doubt everything? Reality emerges. What exists? What is illusion? Planets of belief, accepting uncertainty. And then, I'm not going to read all of the titles, so we could spend the whole hour doing that, but they're interesting. Who am I? Abducting God. Part 3, essence, how much we know, the quantum realm, interpreting quantum mechanics, the core theory. And then part 4, complexity. And part 5, thinking, and deals with consciousness, the hard problem of consciousness. And then appendix, the equation underlying you and me, your favorite equation, Schrodinger's equation on t-shirts and everywhere else. And so let's start with just that. Schrodinger's equation. Mm-hmm. What is it?
Well, we have.
Remember, my audience, by the way,
I understand,
is not so not so familiar with scientific jargon. So sometimes I have to ask these questions.
Of course,
as well. Okay.
Let me actually, get there with a little bit of a digression just to set the stage, because if you go back to the ancients trying to understand the world. And so my ancients are Plato and Aristotle. There are other ancients all over the world that I try to mention in the book, but I'll admit I'm not as familiar with them. But, they conceived the world as teleological, as oriented toward a goal. There were different kinds of objects had natures, right? Aristotle said, well, of course, rocks fall and fire rises because it's in the nature of earth-like things to be down at the bottom and fire-like things to be near the top. And so when Isaac Newton came along, following Galileo and Ibn Sina and many other thinkers, he really turned that entire picture on its head in a way that is really important to try to understand for modern physics, because that's the subject of the chapter that you mentioned called "The World Moves by Itself."
Yes.
The idea is that in order to get something moving, to Aristotle, you have to push it and keep pushing it, right? If you stop pushing your car or stop putting your foot on the accelerator, it will come to a stop. This is true. He was not wrong about this. But the new way of thinking that was brought in by modern physics says, well, that's just because there's friction and air resistance and so forth. The natural way for the universe to be is to continue to move without being pushed. And now we know. Now we send satellites, right? We send spacecraft into space, and they do indeed keep moving even without being pushed. And so that just overturns the entire way of thinking about the world. Rather than thinking about objects as having a natural way to be, there is a pattern. There's a rule. There's a set of equations, if you like. This is where we're getting to the equation. There's a set of equations that tell you if the world is doing one thing right now, here's how it will look the next moment, and then the next moment, and then the next moment. It's an equation for the evolution of the world over time. And of course, Newton did not have the final word. In the 20th century, we replaced Newtonian mechanics with quantum mechanics. And I'm sure we'll go into quantum mechanics because it's fascinating. But part of quantum mechanics still follows the same paradigm. If you tell me the state of the universe now, there's an equation to tell you what's going to happen next. And it's that equation that is in the back of my book.
Okay, so you say there that equation explains what you call the core theory. And the core theory has everything to do with what we call the physical world, and that we don't need to go beyond the core theory to explain atoms, molecules, force fields, and everything that we experience on this planet and in the universe.
That's
And
right.
that core theory, of course, doesn't, or maybe does. I don't know. Does it look like things like dark matter, dark energy, the cosmological constant, which is off, as you say? It's the cosmological constant is the observed value is different than the theoretical value. So the core theory, does it include all of that, all the missing elements in our physics right now? What caused the Big Bang? What
Right.
happened in the Planck epoch? Why is inflation so precise? It's very precise, right? You 10 to the power of minus 30 seconds, 36 seconds to 10 to the power of minus 33. The universe triples in size every trillionth of a trillionth of a trillionth of a second and then slows down. Now we have this. Does the core theory account for all of that?
Certainly not. And it doesn't try to. So the core theory is specifically the parts of physics that we currently understand. It does not include dark matter. It does not include black holes even, much less the Big Bang or something like that, or inflation. But that's the easy part to say. Of course, there's things we understand, things we don't understand. The more dramatic claim, which is contentious, but I think it's pretty obviously, it's not obviously, but I think it's pretty true, it's pretty defensible, is that you and I, everything that happens to us in our bodies, in our brains, in our everyday lives, is explained in terms of the core theory. So it's easy to imagine that there are unknown particles and fields that would be the dark matter or whatever. But we have good reason to believe that those particles and fields, whatever they may be, do not affect us in our everyday existence as we go through the world. So the idea is that whatever we are, whatever vocabularies we want to use to discuss ourselves at the human level, better ultimately be compatible with that core theory.
And the core theory, of course, is what's responsible for all our technology right now. Right?
Absolutely, right.
This conversation we are having, yep. Everything that we assume every day is part of our experience is based on the core theory. But then I want to stretch that a little bit, because dark matter is still responsible for most of the gravity. Mm-hmm. So it does affect this experience, right? The planets are held together by gravity. They spin, they go around this, our planet goes around the sun, and this, everything is moving, as you said. All that invisible stuff is somehow influencing the visible stuff too, right?
Well, this is a very good question, because there's an interesting thing about dark matter. In our galaxy, in the Milky Way galaxy, which has, 100 billion stars or something like that, most of the matter is the stuff we call dark matter, something that we don't think is any particle that has yet been detected by physicists, something is not in the core theory. So if you want to understand the dynamics of the Milky Way galaxy, then you need to go beyond what the core theory lets you do. But here's the difference between ordinary matter and dark matter. When ordinary matter, by which we mean atoms, right? Atoms and molecules, all the particles we do know about, when atoms bump into each other, they can stick. They can make a bigger atom. They could make a molecule, or even they can just slow down by, emitting a photon, losing some energy and so forth. Whereas when dark matter particles pass through each other, they just pass right through. They don't interact. They're very, very weakly interacting as particles. So what happens because of that is that even though there's more dark matter than ordinary matter in the galaxy, ordinary matter can clump together to become very, very dense. So when that happens, here in our solar system, you have the sun, you have the planets, you have the asteroids and so forth. Here in our solar system, the dark matter is completely irrelevant. All of the gravity that we're being influenced by, to an extremely good approximation, is from the Earth, the moon, the sun, the other planets. You don't need dark matter to account for it. When you fly a satellite, when you're Elon Musk and you're pointing a rocket at Mars, dark matter does not come into your calculation to try to figure out how to do that.
You can do that even with Newtonian physics, right?
Exactly, that's right.
Yeah. Okay, so now, since we can't discuss everything, there's a few things that I did want to address. You say cause and effect are not fundamental. You talk about something called conservation of momentum and conservation of information. And I think just those two insights are worth talking about. You addressed them in a way earlier when you said you don't need an agent, a causative agent, that everything evolves on its own, and Schrodinger's equation is the key to that evolution over time. It describes almost every atom, every particle, everything in the universe, just that one equation, which is an amazing kind of
That's right. And I would say,
it's,
the crucial insight here belongs to a French mathematician and physicist named Pierre-Simon Laplace. Around the year 1800, so after, over a century after Isaac Newton. But it was Laplace who really appreciated the implications of Newtonian mechanics more than Newton did. And he's the one who sort of started thinking in terms of conservation, especially conservation of information. The idea that he came up with the thought experiment of Laplace's demon, right? If there were a vast intelligence, it's funny because he never called it a demon. Later people gave it the name the demon, but he said if there was a vast intelligence that knew the position and the velocity of literally everything in the world, at one moment of time, it would be able to use the laws of physics to predict the position and velocity of everything in the world at any other moment, in the past or the future. The information you need to understand the universe is contained in every single one moment of time, which is kind of a remarkable, incredibly powerful way of viewing the world.
So then, if cause and effect are not fundamental, then of course that brings into question everything we have about ourselves, about the way we live our lives, about the meaning of birth, about the meaning of death, about the meaning of everything in between. And if I understand it correctly, mathematics, the way I understand it, and maybe I don't understand it, but mathematics looks at patterns of relationships that are both obvious, physical, perceptual, but also invisible relationships. And that's where you go with Schrodinger's equation. And when you go into these invisible patterns of relationship, you realize that there are certain conundrums that come up, like the arrow of time that you mentioned here, by the way. But you also mentioned something called the arrow of space, and you say that actually the two are related, and the arrow of time may be an artifact. Am I right?
And yeah, no, that is exactly right. And it goes into this whole story about cause and effect, because there's two things that are worth saying here. One is that when I say cause and effect are not fundamental, number one, it doesn't mean they're not real. There's plenty of things that are real but are not fundamental, right? They're just emergent in the bigger world. So that's where the arrow of time comes in, because of course, in our everyday life, you can absolutely attribute causes and effects to things that happen in the world. You're not allowed to be late for dinner and say, well, there's no such thing as cause and effect. Yeah, that's cheating. Okay, that's misusing the ultimate laws of physics. But the other thing is that even at the fundamental level, when we say that cause and effect is not fundamental, it doesn't mean anything goes. those. It doesn't mean there's no structure there, right? There's absolutely a pattern. The way that I like to talk about it, one of the examples I give in the book is if you think about the integers, right? -1, 0, +1, +2, +3. If I give you an integer like 6, and I say, what is the next biggest integer? You can say 7, right? You're very clear that that is a pattern that is going to be there. But you wouldn't say that 6 is the cause of 7. It's just that the relationship that they're in. And so that's the interesting thing that is the implication of Laplace and modern physics more generally, that the fundamental story of the connection between different things going on in the universe is one of a rigorous mathematical pattern, not one of cause and effect relationships.
That's very important because it in a way addresses some deep existential dilemmas, deep existential anxieties, deep existential conundrums, and maybe even existential liberation. All of that, if we understand, if mathematics is in fact what describes fundamental reality, notwithstanding that even in mathematics you have theorems like Gödel's theorem, which are, have nothing to do with logic or algorithms. They just seem to crop up and they're true, even though we can't explain them. But since mathematics is looking at this deep structure of reality, it does address existence. It does address existence and also our modes of experiencing existence. So, at the risk of being a little controversial, in Eastern wisdom traditions, and Schrödinger is seemingly a mentor for you. Schrödinger was a mentor in his philosophical thinking for me, in his philosophical, when I read his book, What is Life? And Schrödinger was also very close to the thinking of Eastern wisdom traditions, Upanishads particularly, and he got that from Schopenhauer. So Schrödinger, in one of his writings, says consciousness is a singular which has no plural. That what that gave me a clue to some of the thinking in the Eastern metaphysical traditions, that we as biological organisms are actually modes of knowing. Modes of knowing. We have 5 senses. We have a mind. We have an intellect. We have an identity we call the ego. And then we have this capacity to come up with explanations. And these are human explanations, obviously, because they're based on human perceptions. And so biological organisms are modes of knowing. So me as a biological organism is a different mode of knowing than a horseshoe crab or a bat or a porpoise or an insect with 100 eyes. So is my mode of knowing actually the only access to reality, or are we just making models of reality through these explanations, and sometimes maybe mistaking the models for what is really, really real, which is almost ungraspable. I cannot, I sit at night, I practice 2 to 3 hours of contemplative meditation for the last 50 years. And, I sit at night and I remember my childhood, this 5-year-old kid, and, the embarrassed teenager, and different body, different brain, different mind. I don't find, in my personal experience, how atoms and force fields can explain this experience that I'm having of actually watching my thoughts, of watching my memories, of watching my feelings, of watching, even worrying about who am I, which you address here in this book. So given all that, is science a way of finding the truth, or is it getting us closer to the truth, or is it a human experience? One day I was sitting with a mathematician from MIT, and and Lawrence Krauss was there, by the way. And Lawrence said, I'm describing the origins of the universe, and this mathematician said, there's no such thing. It's a construct. It's a mathematical construct. There's no such thing as the universe. What do you have to say to all that?
Well, you covered a lot of ground there. There's probably many hours worth of
I
things to
am
say.
laying the case to interview you
Yes.
again. I could do that for the rest of my life.
But let me, let's think about the specific question of reality and models of reality, right? I mean, parenthetically, there's interesting things to be said about human beings and models that they have in their head and information theory and how we sort of conceptualize the world out there. But that is another set of things. Let's think about this ontological question about what is the world. So there are, two traditions. If you want to sort of put them on opposite ends of the spectrum. And one end of the tradition is that our perception or our contemplation or our imagination of the world is primary, right? The idea or the mentality comes first, and the world is sort of a reflection of that. The other tradition is that the world is physical, it's stuff, and that we are just a little bit of the stuff, right? There's some atoms going around in our brain, and we attach words like consciousness and experience to different things that the atoms do. I like the second of those traditions myself, and here's my very, very short sales pitch for it, even though it's certainly not something that everyone agrees about. I find it hard to imagine that if different people looked at the world and sort of perceived in different ways and sort of assigned different kinds of structure to it, that they would ever end up agreeing with each other. The fact that when different people experience the world, they ultimately see a consistent structure. It's not just individual opinions, right? There seems to be something objective and external to our experiences. Gives to me the idea that there is something out there, objective and real and physical, that we are all participating in, that we are all experiencing. And from that perspective, of course, our models of the world will be woefully incomplete because we experience so little of it. Our experience is being driven to new realms by science and technology and experiments and our ability to reach and look at the world in new ways, but it's still very limited compared to everything that there is. So even if every single theory or understanding of the world that we construct is provisional and temporary and incomplete, I do think that we're getting closer to understanding more and more of the world and capturing a very real truth in doing so.
The human world, or the
The
world.
world, no, the physical world. We're learning more and more about the physical world, I think, the real objective out there world.
So, you talk about language a lot, and how language shapes even perception and reality, right? And even our deeper understanding. And right now, the language that seems to be more effective than any other language in describing what we call objective reality is the language of mathematics, right? So this has been asked before. Why is mathematics so unreasonably
Right.
effective? Where is it? Where does mathematics exist in the physical structure of the universe?
Yeah, man, I don't know. That is one I'm actually struggling with myself right now. Supposed to be writing a paper about this, about the philosophy of mathematics, and a lot of people who are professional mathematicians assign or attribute a kind of reality to mathematical truths, to mathematical structures that is different than the physical reality that I was referring to. And the argument is basically like, well, why would physical reality be so well described by mathematics if mathematics didn't have a separate existence all by itself? I'm a little skeptical about that argument. I think that it's kind of mixing up different definitions of the word real or exist. I mean, whatever mathematical realities are, they don't exist in the same way that physical reality does. So maybe we need a different word for describing what that is. In some sense, I'm not surprised that the world is described by mathematics. I don't think it's unreasonable. What is really meant by that claim is that the mathematics we use to describe the world is really beautiful and simple, right? It's not a mess. It's not like an approximation. It's not, noisy. No matter what the world did, we would describe it mathematically, but maybe it wouldn't fit very well. The nice thing is the world is simple and clean at its core. And then through its evolution and through our experience of little parts of it, we see all this beautiful, complex structure around us.
So thank you for that, because that's a little bit of consolation in that both mathematics and physical reality may have the same origin anyway, whatever that origin is. So two more questions, because we are going, after 1 hour, we can't post it if we go beyond 1 hour. One is, I hope you'll come back to talk to me again in the future. Sure. But the second is, you talk here about something which is very important: complexity, entropy, the arrow of time being a result of entropy, but then we have evolution, and life, which is the opposite of entropy. But you say that actually entropy leads to complexity, and that complexity is kind of a very interesting thing. It arises, reaches a peak, and then it starts to dissipate as well. And so from your description here, the physical laws of nature actually are sufficient to describe both the arrow of time, complexity, and even life.
That's right. And again, these are very, very incomplete. When I talk in the book about fundamental physics, we're on pretty firm ground. There's a lot we know. But when I talk about things like the evolution of complexity or the origin of life or the nature of consciousness, here we're in scientific realms that are just not complete yet, right? We're nowhere near understanding the final story for these. I nevertheless try to make the case that when we do understand the final story, the way to bet is that it will be in this physical paradigm, in this poetic naturalism framework, right? And so this story that you mentioned of entropy increasing, entropy being a way of characterizing the disorderliness, right? The randomness, the disorganization of something. It would seem naively, straightforwardly, that if over the history of the universe, entropy increases, that the universe should become less and less organized, right? It's almost by definition. And in some sense it does, but in another sense it doesn't, because I try to point out that simplicity versus complexity is a different axis than low entropy and orderly versus high entropy and disorderly. And if you're very, very, very simple, then you're very, very low entropy. I should say that the other way around. Sorry. If you're very, very low entropy, you will be simple. If everything is in the corner of a room and the rest of the room is empty, that's simple. If you're very, very high entropy, if all the gas in a box is filling the room, you're simple once again. Complexity will only happen in between low entropy and high entropy, because that's when there's enough room to do interesting things, even though you're not filling up the space. And that's what time gives us. Time takes us on a journey from low entropy to high entropy, and that's why complex structures can evolve. So you're right. I like to undo the conventional wisdom that says that entropy is working against complexity and organization. It's the increase of entropy that allows complexity and organization to come to be. And having said that, let me be super duper clear here. We don't understand it. We do not have the complete picture of this. We're writing papers about this now. We're trying to understand it at a more scientific level. I think this is a wonderful, intriguing research frontier for modern science.
It certainly opens a door to one modality of investigation. So before we end, I want to talk very briefly about this book, because it takes off in a direction that I had not anticipated. So right now, if I go on Wikipedia and I look at, interpretations of quantum mechanics, nobody questions the math the calculations and the effectiveness that all our technology today depends on it. But then you come across maybe 30 interpretations, including some very interesting ones like time symmetric interpretation of quantum mechanics. That the future determines the
Right.
present and the past, weak measurements are and off, and then there's all this instrumentalism, and it's enough to give you a headache. But your take, notwithstanding that most people think of quantum mechanics still in the Copenhagen terms, your take is based on Schrodinger's equation. If you allow it to evolve, then there are infinite universes.
That's right. And
Earlier, but I had read, but I also saw in one of your talks, and I'll stop after that because I want you to have the last word. But you know, if there are really 2 trillion galaxies, observable galaxies or possible galaxies, then planet Earth is not even a grain of sand in all the beaches of the Earth. And on that grain of sand, you have a biological organism called Homo sapiens. We gave ourselves the name, the wise ones. And then this biological organism actually can explain the mysteries of the universe in this little bit of junkyard of infinity where we are. You know, uh, that to me itself is totally mind boggling. 2 trillion galaxies, but you're going even beyond that. You're saying infinite and infinite observers of those galaxies, because the observer and observed are kind of both the activity of the total, whatever it is, the total mystery.
yeah, it reminds me once I was on Science Friday, the NPR show, and Ira Flato said, you cosmologists say you only understand 5% of the matter in the universe. 25% is dark matter, 70% is dark energy. Isn't it embarrassing that we only understand 5% of the universe? And I said, no, no, no. Like, we understand 5% of the universe. That's amazing. The universe is very, very big. We should be very, very happy with that. And the only reason we're able to say that we understand even that much is because of the leverage that we are given by the laws of physics. And this may or may not be, a good way to go through life, but the way that has succeeded for scientists is to be what John Wheeler called being radically conservative. And what he meant by that is you should, when you imagine how the world works, you should be conservative in the sense you should stick as closely as possible to what we know about the world works, right? Like, we have laws of physics. You shouldn't just change the laws of physics in your mind because you don't like them. You should trust them for a while, but then you should be radical to the extent that you take those laws and you extrapolate their implications, and you take that extrapolation seriously. You say, even though there's a star in another galaxy very, very far away that I've never seen, that I never will see, it's a tiny little star, it's invisible to the naked eye, etc., right? But I bet that the nuclear fusion processes going on in that star follow the same rules as the ones in the sun. That's what the laws of physics would say, and the radically conservative point of view says, until we know better, let's accept that. If we know better, then we can change our minds, but until we know better, that's the way to think. And that's the origin of this many worlds of quantum mechanics idea also. We have Schrodinger's equation. We have these rules that do such a good job at accounting for the experiments we see, the technology we build, etc. And if you take those rules at face value, they imply that every time you make a quantum measurement of a spin or an electron or Schrodinger's cat or whatever it is, different copies of the universe are produced where different measurement outcomes come true. That's an implication of the theory, of the math, of the equation. And so unless you have a reason not to accept that implication, the simplest thing to do is just accept it. And in some way, that's what I try to argue for in Something Deeply Hidden, that it doesn't hurt you. It's not something to be bothered by. And if the equations say so, and it helps us understand what's going on in the world, then we should accept it and provisionally take it seriously.
And we who are trying to understand are also made of that 5% of stuff, right?
We are.
We are. Okay, I don't want to talk more because there's so much material here. I want to come back if you're willing. Maybe we can even do a series on some of the elements here. I've done a series recently with Don Hoffman, who was a student of Crick. And, Crick charged him with astonishing hypothesis. I want you to show me how neural networks produce consciousness and everything that we experience. And Don tried for 30 years, and he now has written about the case against realism. And he makes some very convincing arguments against realism, that what we observe is real. You talk about illusions here as well. And, Wittgenstein said, our life is a dream. We are asleep. Once in a while, we wake up enough to know that we are dreaming, that what we call the physical world is an interpretation of an intermittent stream of perceptions, and how we actually interpret those perceptions. So I wanted to actually conclude with a very interesting insight that you may or may not be familiar with, because you quote Aristotle all the time. Aristotle was a teacher of Alexander the Great. As you know, Alexander the Great came to India in 323 BC, and he died prematurely at the age of 32. But there was a meshing of two cultures, the Greek culture and the Vedantic culture. And in that, there is something called non-dualism, which is exactly what you're talking about, the ontology, the fundamental nature of existence. Last week, when I spoke to Frank Wilczek, he said, fundamental reality is only three things: mass, charge, and spin. And then he said, mass, charge, and spin are structureless entities which have no volume, which have no shape, that have no structure, but they define everything in existence: mass, charge, and invisible entities. So my ask from you is, it doesn't matter what we call this fundamental reality: mass, charge, spin, matter. It's still a mystery. Has science increased our ignorance or our knowledge of this mystery that we call existence?
Both. That's the great thing, right? We certainly know more about existence than we did, more than Aristotle and Alexander did. But we also know so much more that we don't know. Aristotle did not worry about quantizing gravity. That was not something that he had in mind. He didn't even worry about the arrow of time, because for Aristotle, the directedness of time was just taken for granted. It wasn't a puzzle to be solved. That puzzle did not become puzzling until the time of Laplace, right? So when we increase our knowledge of the world, when we understand more and more of the structures out there that we see, it's very natural that the number of questions we have also goes up. David Gross, the Nobel Prize winning physicist, likes to use a metaphor of the sphere of knowledge. He thinks of ourselves as living within a sphere of knowledge, and we push it out. We enclose more and more volume, so we know more and more within the sphere of knowledge. But the area of the sphere between our knowledge and our ignorance is also growing as we push it out. So I think that's the least surprising thing in the world, and that's the tricky part of having these conversations in a principled way, to recognize both that we do know some things and that we don't know everything, and to draw the line in the right place.
I think we can stop there. These are two amazing books: The Big Picture on the Origins of Life, Meaning, and the Universe Itself, Something Deeply Hidden, by Professor Sean Carroll. You can read all about him, so I'm not going to tell you that he's one of the most important luminaries in science and in physics and theoretical physics, one of the most important people in the world. So you'll be missing something if you don't read these books. And Sean, I have to say, I read everything about you, but then when I read that you have the same desk as Richard Feynman, that made my day. So thank you for joining me.
I haven't been there for a long time because of a global pandemic, but yes, it is in my office at Caltech.
Yeah, well, hopefully it's going away, the pandemic.
I hope so.
And all
I
this
do.
stuff. Thank you, sir.
Thank you very much for having me on, Deepak.
Great privilege. Great privilege.
Thanks.
Thanks.